Hey guys, so today we are going to be looking at two problems where we're going to be finding least squares solution of ax equals b. Um, we are going to be using least squares and then also QR factorization. So what we're doing is ultimately we are solving for x hat. So this least squares solution is as close as you can possibly get to the real solution, to x. And once we have our x hat approximation, we're going to use that to find the error. So to start, problem number one, find the least squares solution of ax equals b, and find the error of the solution for a and b are given. As I said, ultimately we want to find x hat. To start, we have this equation, a transpose times ax equals a transpose times b. As you can see, we are given a and we are given b, so all that's left is to find a transpose. And that's pretty easy. You just take the first row of A and make that the first column of A transpose. Second row becomes second column. Third row becomes third column, and so on. So you have A transpose. It's pretty straightforward. So now we have A transpose, we have A, and we have B. We can start plugging things in. We can start solving. So to start, we are going to find A transpose times A. So A transpose is what we just found. A is what we are given up here. Using matrix multiplication, we are going to get this matrix. So that is our A transpose times A. So now we want to find A transpose times B. A transpose times B, which is B is what they give us. And we see these two inner numbers are the same, 6, 6. Same with up here, 6 and 6. So that means they can be multiplied together. And what you're going to get is going to be these two outer numbers. So 4 by 1, the two outer numbers here, 4 by 4. So when you multiply these two matrices, basically what you're doing is -3 times the first row plus -1 times, or column rather, times the second column, 0 times the third column, 2 times the fourth column, and adding them all together. So we get 4, -4, 2, and 6. So we have found A transpose A, and we found A transpose times B. Now, put them together, and we can start solving for our x. A transpose A, what we solve for up here, times our x vector equals our A transpose times B that we solved here. So using this matrix equation, we are going to augment it and start row reduction operations in order to get our reduced row echelon form. So using our operations, we just do what we do, find the zeros. We want to get that diagonal, so we're just using the different operations. And eventually we have our reduced row echelon form. So we have ones on the diagonals, zeros in all the pivot columns below the ones. And we see that we only have 3 pivot columns, but we have 4 columns total. So we're going to have a free variable. So x4 is going to be free. And then we're going to use that to find the rest of our x's. So we have x4 is free. And then next, we're going to have x3 minus x4 equals -2, as we said here. And then x2 minus x4 equals -5. And 1 times x1 plus 1 times x4 equals 3, right here, with x4 being free. So we can solve all those to get our x1, x2, x3, x4. Basically just bring the x4s, either add it in these two cases or subtract it in this case, over to the right side. So we have x1 equals 3 minus x4, x2 equals -5 plus x4, x3 equals -2 plus x4, and x4 being free. So putting that into its right form, we have our approximation. We've solved for x hat. X hat equals our particular solution, which is the 3, -5, -2, 0, because x4 is free. We have 0 here. And then our general solution containing x4 is x4 times -1, 1, 1, and 1. So particular solution, general solution. We have solved for x hat. So that's our least squares solution of ax equals b. That's as close as we can get to the real x value. So now we want to find the error between x and x hat. But because we have this free variable, we don't want that here. So basically we can plug any value in as x4. And to make it easy, we're just going to choose to set x4 equal to 0 so that this x0 times this column vector is just going to become the 0 vector. So we're just left with the specific particular solution of x hat. And in order to find error, we know that error is the length or magnitude of b minus b hat. So we have b because they gave us b, and we just need to find b hat. So b hat equals a times x hat. They give us a, we just solve for x hat equals 3, -5, -2, 0. So b hat, a, x hat, multiply them together using matrix multiplication. We get 3 times the first column plus -5 times the second column plus -2 times the third column and plus 0 times the fourth column. And then multiplying the scalars and the column vectors and then adding them all together, we find our b hat. So b hat equals this matrix right here. And now that we have our b hat and we know b because they gave it to us, we can start to find the error. So error is the length or magnitude of b minus b hat. So b was given to us, -3, -1, 0, 2, 5, 1. B hat we just solved for right here. So we have -2, -2, 1, 1, 3, 3. Subtract that from b, and we get -3 minus -1 becomes -3 plus 1, negative -3 plus 2 rather becomes -1. -1 minus -2 is -1 plus 2, it's 1. 0 minus 1 is -1. 2 minus 1 is 1. 5 minus 3 is 2, and then 1 minus 3 is -2. And so now we want to find the length of that. To do that, we square each of these values and add them all together and take the square root. So -1 squared plus 1 squared plus -1 squared plus 1 squared plus 2 squared plus -2 squared, as we have it here. And then you square the whole thing, and we're going to get square root of 12. So this is our error from our x to our x hat. So the approximation of what we found as close as we can possibly find the real value of x is what we found. So we found x hat. And so the error from x hat is given by what we found here. So to recap, we found our least square solution, x hat, and then we found our error. Now moving on to the second problem, we want to determine the QR factorization of A. Then use the QR factorization of A to find the least square solution of ax equals b, and then find the error of the solution where A and B are given. So we want to find first Q, and Q is the orthonormal basis of A. So that means that it is both orthogonal and normal. Right now, A is neither of those. Orthogonal means that when you multiply any of the two vectors, the dot product of those two vectors is going to be 0. And then normal means whenever you find the length of the vector, that length is going to be 1. Right now, that is not the case for any of these vectors. So first, to start off in finding Q, we need to find an orthogonal basis of A. That's our first step. So to find an orthogonal basis, we're going to call this x sub 1, this x sub 2, and this x sub 3. We want to find v sub 1, v sub 2, v sub 3. This will be our orthogonal basis. Start off by finding v sub 1. We're just going to set x sub 1 equal to v sub 1. So v1 is going to be 1, 1, 1. It's going to be the first column of A. Easy, simple. Moving on to v2 now. We have this equation right here. V2 is going to equal x2, so the second column of A, minus the second column of A dot V1 over V1 dot V1 times V1. So we're going to use the dot product a lot here. So plugging in what we know, we have the second column of A, the second column of A, our first vector over our first vector dot first vector. We're going to multiply it by the first vector again. So to do the dot product, you are basically taking the sum product of these two vectors. So you're going to multiply this and this value, and then you're going to add it to the multiplication of these two, and add it to the multiplication of these two, and so on. So it's going to be 3 times 1 plus 1 times 1 plus 1 times 1 plus 3 times 1. So that's 3 plus 1 is 4 plus 1 is 5 plus another 3 is 8. So that's what you have here. And again, 1 times 1 plus 1 times 1 plus 1 times 1 plus 1 times 1. So that's 1, 2, 3, 4. So 8 over 4, that becomes 2. Multiplying that by V1, we're just going to get 2, 2, 2, 2. So subtracting that from our second column, we get 3 minus 2 is 1, 1 minus 2 is negative 1, 1 minus 2 is negative 1, and 3 minus 2 is 1. So we have our second vector. We found our first vector, we found our second vector. Now we're going to move on to find our third vector of the orthogonal basis of A. So to do that, we have this equation. It's a little bit longer than finding our V sub 2, but it's the same process pretty much. So we're taking our third column from the matrix A and subtracting from that the third column dot V1 over V1 dot V1 times dot V1 minus our third column of A dot V2, which is what we just found here, over V2 dot V2 times V2. So plugging in all of our little column vectors, we have this, and we're going to just take the dot products of all of these. And so we get our third column minus 10 comes from 5 times 1 is 5, plus 0 times 1 is 0, so 5 plus 0 is 5. And then plus 2 times 1 is 2, 5 plus 2 is 7, plus 3 times 1, so that's 7 plus 3, that's 10. And then 1 times 1, 1 times 1, 1 times 1, adding these all together, that's 1, 2, 3, 4, 10 over 4. Moving on to this one, we get 5 times 1 plus 0 times negative 1, so that's 5, plus 2 times negative 1, so that's 5 minus 2, that's 3, plus 3 times 1, so 3 plus 3 is 6, and then, again, 6 over 4. We're going to simplify these and multiply this, the third column of A, by 2 over 2, just so that they all have the same denominator, so that it's easier to subtract them from each other. So this becomes, you can take out a 2 over 2, so it becomes 5 halves. So you multiply 5 halves by V1, then this one becomes 3 halves. Multiply that with V2, and once you subtract them, you get 10 over 2 minus 5 over 2 minus 3 over 2. That becomes 10 minus 5 is 5, minus 3 is 2, so you get 2 over 2, which is 1. 0 minus 5 over 2, that's negative 5 over 2, minus negative 3 over 2. So that becomes negative 5 plus 3, so that's negative 2 over 2, simplifies to negative 1. 4 over 2 minus 5 over 2 is negative 1 over 2, minus negative 3 over 2 is negative 1 over 2 plus 3 over 2, so that becomes 2 over 2, 1. And then 6 over 2 minus 5 over 2 is 1 over 2, minus 3 over 2 is negative 2 over 2, so you get negative 1. So we found our third vector in our orthogonal space. So we found V1 using this equation, we found V2, and then using this equation, we found our V3. So this is the orthogonal basis of A. So we're just one step closer to finding Q. We can check that it's orthogonal by taking the dot product of any of these two vectors, and we're going to see that we get 0. So just to check, 1 times 1 plus 1 times negative 1 that's 1 minus 1, so that's 0, plus 1 times negative 1 is 0 minus 1, so that's negative 1, plus 1 times 1. So that's negative 1 plus 1 is 0. So the dot product of these two is 0. Now taking the dot product of these two, we get 1, negative 1 times negative 1 is positive 1, so that's 2, minus 1, minus 1, you get 0. Dot product of these two, the first and the third vector, we get 1 times 1 is 1, minus 1 times 1 is 0, plus 1 times 1 is 1, plus 1 times negative 1, so 1 minus 1, it's 0. So the dot products of any two of these is going to equal 0. So we know it's an orthogonal basis. But now we want it to be normal as well, because Q is the orthonormal basis of A, meaning that the length of any vector is going to be 1. And if we check that right now, we're going to see that it's not equal to 1. So finding the length, it is the square root of each of these squared added together. So it's the square, so it's 1 squared plus 1 squared plus 1 squared, all under the square root. So that gets us square root of 4, which equals 2. So that is not equal to 1. So we know that it's not normal. So we need to normalize it. To do that, we do this. So we take 1 over the length of V1 and multiply it by V1, and same with V2 and V3. So we're just dividing the vectors by their lengths. So first, we're going to solve for 1 over the length of V1. And we have up here, V1 is 1, 1, 1, 1. So it's 1 squared plus 1 squared plus 1 squared plus 1 squared. 1 over square root of 4 equals 1 over 2. And then we have 1, negative 1, negative 1, 1. Squaring each of those, adding them together under the square root, we also get 1 over square root of 4, which equals 1 over 2. And looking at our third vector, 1, negative 1, 1, negative 1, it's the same case. 1 squared plus negative 1 squared plus 1 squared plus negative 1 squared equals 1 over the square root of 4, 1 half. So the length of all of them is 2, so dividing the vectors by their lengths. So basically just multiplying each of these by 1 half. We have normalized our orthogonal basis. So we get 1 half, 1 half, 1 half, and so on. So now we have found Q. Q is the orthonormal basis of A. And now that we have Q, which is here, we take the vectors, put them into our matrix. We can use that and A to find R. So we know that A equals Q times R, and we want to get R by itself. So we multiply both sides by Q transpose. Q transpose A equals Q transpose times Q times R. And we know that Q transpose times Q just equals the identity matrix. And the identity matrix times R just equals R. So we have that Q transpose times A equals R. So Q transpose, we're taking the transpose of Q. Again, it's just taking the first row, making that into the first column of Q transpose. Second row of Q becomes the second column of Q transpose. Third row of Q becomes third column of Q transpose. Same with the fourth one. And then we were given A, so we are going to multiply these together to get R. We see that this is a 3 by 4, this is a 4 by 3. The 4s on the inside match. So what we're going to get, our R, is going to be a 3 by 3. And so doing matrix multiplication, this is what we get. And notice that it is an upper right triangular, as it should be. It's a quick check. If you don't have zeros under your pivots, then you did something wrong. It should be in upper triangular matrix, and that is our R. And so we want to recall what we're doing. We're trying to find the solution of AX equals B, so we're trying to find X hat. We don't want to lose sight of that. We have found Q, we have found R. We know that A equals QR. So replacing A with QR, we get QR X equals B. And Q transpose times Q, the Rx equals Q transpose B, just moving the Q over, because we remember that Q transpose times Q equals the identity matrix. The identity matrix times R just equals R. So we have Rx equals Q transpose B because we're trying to find that X hat. And so we found R up here. All that's left to do is find Q transpose times B. So we have our Q transpose that we found earlier. B was given to us. This is a 3x4. This is a 4x1. 4 is on the inside match, so we're going to get a 3x1. So it's 3 times the first column plus 5 times the second column plus 7 times the third column plus -3 times the fourth column. Add those all together, we get 6, -6, 4. So that's our Q transpose times B. We have Q transpose times B. Now we can finally solve for our X. So we have this matrix equation right here, our R that we found earlier, and the Q transpose B that we just found, and we want to find our X hat. So we augment it, and we don't have to use row operations on this one. We can just solve it. We start at the bottom. Because we have this series of linear equations, the system of linear equations. So starting at the bottom, we have 2x3 equals 4. So getting x3 by itself, we have x3 equals 2. And then plugging our 2 in for the x3 for our middle equation. Trying to solve for x2, we have 2x2 plus 3 times 2 equals -6. 3 times 2 is 6. Move that over to the right by subtracting. We get -6 minus 6 is -12. Trying to get x2 by itself, we divide by 2, divide by 2. So our x2 equals -6. And then we have x3 and we have x2, so we can plug those in to our top equation to solve for x1. So 2x1 plus 4x2, so 4 times -6 is -24, plus 5 times 2. 5 times 2 is 10, -24 plus 10 is -14. Add it over to the right. So 2x1 equals 20. Divide by 2, divide by 2, we get x1 equals 10. And so this is our x hat. So we found the solution to ax equals b. It's our x hat equals 10, -6, 2. This is as close as we're going to get to the real solution. So now that we have solved it, we want to find the error. To do this, we now have x hat. We just need b hat, because remember the error is the length of b minus b hat. And so we have b, we have a, we have x hat, because we just solved for it. All we need is b hat. So solve for b hat, it's b hat equals a times x hat. A was given to us, x hat we just solved for. So multiplying these two matrices, this is a 4x3, this is a 3x1. We can multiply it because they both have 3's in the middle. So we're going to 4x1 matrix. And once you multiply it, you're going to get 2, 4, 8, -2. So this is b hat. We have b hat. Now we can find the error. This is how we find it. We're going to take the length of b minus b hat. So b was given to us. It was 3, 5, 7, -3, minus 2, 4, 8, -2. So 3 minus 2 equals 1. 5 minus 4 equals 1. 7 minus 8 equals -1. And -3 minus -2 is -3 plus 2. So that equals -1. And then we just need to find the length of that. So we square each of these and then add them together and take the square root of the entire thing. So it's 1 squared plus 1 squared plus -1 squared plus -1 squared. So we get the square root of 4, which equals 2. So that's our error. That's our error between the real x and the estimation of x, which we solved for using the QR factorization. So again, we found x hat, and then we found our error. Thank you for watching, and have a great day.